We are studying now hypothesis test. Today's topic is significance level, say alpha. It is a little complicated concept, terminology, so I think you may understand this terminology. Okay, hypothesis testing involves making decisions about the parameter based on sample, okay, right? Which means that errors can occur in decision, making decision, because we have to decide some decision based on a sample. For example, let us consider the process by which a judge make a ruling on the defendant A in a courtroom. This is, A is a suspect, murder suspect. Okay. In this case, the hypothesis will be, we already took this kind of example. A is not criminal. H1, A is the criminal. The data sample needed by the judge to make a ruling includes evidence, testimonies, etc. The judge rejects H0. Reject H0 means concluding A is the criminal. When in fact, H0 is true. A is not the criminal. In fact, H0 is true, then the judge has made an error, right? The judge rejected H0 means A is criminal. But when in fact H0 is true, then the judge has made an error. Such errors should not occur frequently. This type of error is called type 1 error. Okay? Type 1 error. The probability of making this type of error is referred to as significance level. And we denote by A, alpha, sorry, not A, alpha. In summary, in the equation, alpha equal to what? H0 is true, base, this is given, reject H0, like this, okay? Equal to probability making type 1 error. You have to understand this relationship. Alpha is like this. Significance level alpha is often predetermined when conducting hypothesis testing, and it is commonly set alpha equal to 0.05, 5%. Here, alpha can be understood the same value as alpha when referring to the confidence level 1 minus alpha 100%. So that's why when we study confidence level, the confidence level is 1 minus alpha 100%. Okay? Although confidence interval estimation and hypothesis testing are closely related, but they are not same. Okay? Very closely related. So the theory of testing hypothesis is based on estimation. So we, took that process. All right, let's see. Let's continue with the hypothesis testing for the biased coin. We discussed in the previous example, there is a biased coin and we want to test, okay, probability of H is not equal to 0.5 because the coin is biased. Suppose the sample size is n equal to 100 times we toss that biased coin. The tested statistic can only be x, which is the number of times heads comes up in 100 tosses. If heads comes up only 25 times, okay, out of 100 times, the null hypothesis will be rejected. Why? Because it is too small, 25 times only. Then heads up, so it is too small, so the null hypothesis will be rejected. We take O. Probability of a head is not equal to 0.5 because the coin is biased. Okay? However, if high, highly precise equipment measures the balance of a coin and determines that it is perfect, it is perfect, oh, perfect coin, okay, meaning that probability of heads and tails are equal. Okay, high precision equipment measures the balance of coin and determines it is indeed unbiased. This one, it is, sorry, it is perfect. I mean, very fair coin, meaning that probabilities of heads and tails are equal. Okay, then rejecting the null hypothesis based on sample result. What is sample? 25 times 25 heads in 100 tosses constitute an error. This type of error is called type 1 error. Okay, you understand this? By some very precise equipment, the coin is fair, but the result sample is 25 times heads out of 100 times toes. Then we reject H0. Okay, it is biased, okay, based on sample. But it is really very unbiased coin, okay? Then this decision is an error. So that kind of error is type 1 error. What was it? Probability of H0 reject, but H0 is true. This one is a type 1 error. The probability of this is, say, significance level. We even say, even with the fair coin, okay, fair coin, really fair coin, it is possible for heads to come up 25 times out of 100 tosses. However, this kind of probability that happening is very, very small. Understand it? Okay, this is significance level, okay, say alpha. I hope I made an error here, biased, not biased, perfectly fair. Sorry about that. And today, that is it. Thank you. Bye.